Hi, my name is Jason Lee, and I'm part of Senior Design 2 Team 14. Our team name is the Green Crusader, and our project is the Dynamic Speed Bump. Now, what we will be going over today in this WebEx presentation is revisions for our input designs based on our manufacturer's requests. And I'm also going to talk about how we will be implementing two different turbines, one drag turbine and another lift turbine. Also, I want to discuss about our new idea for the storage tank, as well as new parts that we have purchased and what are their purposes and some upcoming goals. Now, for the input design, a couple changes that we had to make was one, our inner diameter of the piston chamber was originally 10 inches, but the problem with that is we couldn't find a standard size rubber O-ring. Therefore, our manufacturer requested us to reduce the size of our piston into a smaller diameter, so we changed it to 5 inches diameter, but that should be no problem, and it can still deliver the desired pressure we need. Also, another change that we made is that with the top, since the piston chamber is a cylinder, we are going to need to cut off part of the top, and then what we would then need to do is bolt in the top part into the sidewalls. But bolting it into the sidewalls should be no problem because the walls around our piston chamber are all an inch thick. Now, this is our newly designed lift turbine, and what we have over here, this is the wind lens for it to help guide the stream of airflow coming out of our storage tank. This is just a picture of one of the individual blades. The blade is a NACA 63215, and the purpose of constructing a lift turbine is because in our calculations we have found that this produces a greater coefficient of lift. But for our testing purposes, we will be building both the drag as well as the lift turbine, and then we are going to compare the data and to see which one delivers the most power. Now, the new idea for the storage tank, first let me talk about our original idea. Our original storage tank was going to be a solid rigid tank. But the problem with this is we want to implement a relief valve, and let's say hypothetically we set the relief valve to 100 psi, and we're building up that pressure from the impulses of our piston from cars driving over the speed bump. Now, once it reaches 100 psi, the relief valve would then open up and release pressure, but as soon as it drops below the 100 psi mark, the relief valve would then be closed again. That does not fit our application, and what we desire is for as soon as the relief valve to open up, we want a constant stream, and we want the storage tank to go from the pressure we set it to atmospheric pressure. So what we have decided on is building a bladder or an expanding tank. The purpose of this is so as the impulses are going over the speed bump, the pressure is being increased, but since the tank is expanding, the volume increases, therefore the pressure isn't really increasing as much. But then as soon as the tank has expanded to its maximum expansion, then what the relief valve would then do is open up the relief valve, therefore letting a constant stream being delivered to the turbine. But since the tank is now closing back up, the tank will then increase pressure to continue the airstream being delivered to the turbine. And also some new parts that we have purchased. We purchased a couple LED light bulbs, and that's going to be our testing, for testing purposes, to see if the power we generate can power these LED light bulbs. And also we have purchased another alternator, so then we can do two testing at the same time to compare our results from the lift turbine as well as the drag turbine. And now a couple upcoming goals. We have my team and I, we will be working on figuring out how to enclose our whole system and building supports for the fluid conduits and the storage tank, etc. Also, we have the wind lens for the lift turbine completely constructed, so we will be sending it out and begin manufacturing and machining it. Also, what we need to do is begin machining the top part of the speed bump, like the physical speed bump portion of it. And we will continue updating the document. And one thing I would like to mention is we spoke with Dr. DeLoyan today. He gave us some very great advice. And on top of that, we discussed about spacing and where we can physically build our device. And this is it for today. Thank you very much and enjoy your weekend.